problem of the day number 8. For the next couple of days, we're going to go over typical types of problems that show up related to transformations of graphs. Okay, so first of all, if they ask you to graph and describe the transformation from the parent graph, and this is your function, first thing I would notice is that this is a square. So we know that it's quadratic, and this is the original way that it would look. And then I would identify each of the variables. So remember, A tells you two things, whether it's going to be right side up or upside down. And it also tells you the vertical stretch or compression. The H tells you the horizontal shift left or right, and the K tells you the vertical shift up or down. So in our equation, we can see that this A tells us that the A is 3. Okay, this is our H. And remember, H is always the opposite sign of what you see. So if you see a +1 here, that means that our H is a -1. And our K is the same sign as what we see. So that means that our K is -4. Okay, and then let's talk about what that really means. So because A is positive, that means it's going to be right side up. Okay, and because it's greater than 3, that means it's a vertical stretch by a factor of 3. If only I could spell. Okay, vertical stretch by factor of 3. Okay, H is a -1, which means that it's being shifted left 1, right? Because positive H means that it's being shifted to the right. Negative H means it's being shifted to the left. Okay, K is negative. So again, K positive means it's being shifted up, and K negative means it's being shifted down. So K is -4, it means that it's shifting down 4. And so then all we have left to do is to graph it. So first thing I would do is graph the H comma K, because that's going to give you the vertex. So our H comma K is -1 comma -4. So I'd find -1, -4, and that's where our vertex is going to be. And then from here, there are a lot of different methods that you could use to graph it, but that kind of requires a little bit more memorization of graphs and what they look like. And personally, I don't like memorizing things if it's easy to figure out. So from this vertex, I would just plug in a value of X to the left or to the right of it. So this value of X is -1, so I would just plug in when X is, for example, 0. Okay, so in the original equation, if X is 0, and then you can do this math in your head. So order of operations, 0 plus 1 gives us 1, then you square it, 1 squared is just 1, times 3, which gives us 3, and then -4, which gives us -1. So when X is 0, we got Y is -1. And then we would use symmetries, right? So we know that the vertex is here in our quadratic, and it's always symmetrical about the line that goes through the vertex. So if we have a point as 0, -1, so it's 1 away from the vertex, that means that we're also going to have a point over here because of symmetries. So 1 to the left of the vertex is also going to have the same Y value. Then plug in at least another point to find another point on the graph. So the next point would be when X equals 1. Okay, so when X equals 1, we have 1 plus 1, that's 2, square that is 4, times 3 is 12, -4 gives us 8. So when X is 1, then our Y is 8. So we have a point here, and again, use our symmetries to get another point at -3, 8 over here. And then do your best to make it a nice smooth curve. Now this is really honestly the hardest part, at least for me, because I'm just not very good at drawing, but I'll do my best to make it a nice smooth curve. Okay, and then that would be our final answer. So we have, these are our transformations. Right side, it's right side up, and it's a vertical stretch by factor of 3. Shifted to the left 1, shifted down 4, and this would be our graph.